What we've got here is an algebraic equations problem featuring geometric forms, featuring a diagram. And the strategy that I've been emphasizing in class for how you deal with these questions, let's get a little green color here, is when you're looking to solve them, you're trying to find a way to write an equation where you have two different ways of writing the same information. And when you find two different ways of writing the same info, sometimes it can be something like it'll give you the perimeter of the square and it says that's equal to 36. So you put 36 on one side of the equal sign and the algebraic expression for the perimeter on the other. Uh, you're setting up an equal sign between two things that are the same. Because remember, an equal sign is just a scale that's showing that it's balanced. If you don't put two things that are the same as each other on either side of the scale, it won't be balanced. Whereas if you do, it will. You'll be respecting the equal sign. So usually the main challenge in these problems isn't solving the equations because the equations aren't too difficult compared to other ones you've seen, but it's figuring out how to write that equation. Unlike the other equations problems we've seen where there haven't been diagrams, there's typically not a let statement here. So your step one, where you go hunting for a let statement, you don't have to do it when there's already a variable that's assigned to the question. That's what we're seeing here. The x is already in there. You don't have the freedom to decide, okay, well, I'm going to say, like, let P represent the perimeter of the square. Instead, you got to go with x because it's showing up in these expressions here. Likewise with writing expressions. Sometimes you might find a problem where you'd want to write an expression. Like at this point, you could start thinking about perimeters because it's telling you, oh, the perimeter of this isosceles triangle might be significant. So you could start doing that at step two. In fact, let's do that here, right? Let's look at this diagram, the isosceles triangle. It's only giving us two sides, but we know in isosceles triangles, this little sign here means these two sides are equal to each other. So we know, and I'm going to write this in on my diagram to give my brain a little less to think about, that this missing side, is a 3x plus 1 centimeters. That's how long the side is. And for this square, likewise, I'm going to put 2x minus 1 centimeters all the way around. 2x minus 1 centimeters everywhere here. 2x minus 1 centimeters. Okay, so I've got all this information poorly written into my diagram. It'd be easier with a pencil, but there we go. So I can actually, if I want to at this stage in step two, write my expression. Let's try my expression for perimeter of triangle. And I can already see perimeter is what you get if you add up the three sides. So I'm going to write that like this, 6 minus x plus, instead of writing this out twice, which I could do, I'm actually going to be a little lazy here and do 2 times 3x plus 1. So this all in centimeters, which I can really just put the units on at the very end. That's my algebraic expression for the perimeter of the triangle. The perimeter of the square I can likewise figure out at this point here. I've got four sides that are all 2x minus 1. So let me write 4 times 2x minus 1. That's the perimeter of my square in centimeters. But really for these diagram problems, the real thinking comes at figuring out how to write your equation here. Because I've invested some time in writing my expressions, I'm going to write them here without units here. I got perimeter of the triangle, and I've got the perimeter of my square. And here's the important point. I've identified that they are the same. Sometimes you'll see the word equals sneaking around in your problem, or the same. Whenever you see two things that are the same as each other, that's what you want to clue in on. That means that this amount here, the perimeter of the square, is the same as this amount here. That means if they're the same, I can put an equal sign between them. If I've properly set up my equation now, solving it should be the easy part, right? Here I got 6 minus x plus 6x plus 2 is equal to 8x minus 4. And then I'm going to simplify here, minus x plus x, that becomes 5x plus 8 equals 8x minus 4. Let's get the x's together, minus 5x minus 5x. I got 3x over here and just 8 over there. I'm going to shift my screen up a little bit so we can see what I'm doing. So I got this equation 8 equals 3x minus 4. At this point, I know I'm going to try and get x all alone. I got 12 is equal to 3x. Let's divide both sides by 3, divide by 3, and I get x equals 4. Now, if x equals 4, let's go back and see if this makes sense in my diagram, right? If x is 4, that means this actual side length here, 3 times 4 plus 1, that's 13. Likewise over here, that's 13. And 6 minus 4 would make this 2. You see this diagram's not to scale, you can see that. But 13, 13, and 2, that means my perimeter of my triangle is 28. Over here, if x is 4, 2 times 4 minus 1, that gives me 7 for all 4 sides, which 7 times 4 gives me 28 as well. So I am getting the same perimeter for both of them. That means I've found the right value for x. But I haven't finished the problem, right? The question is, what is the area of the square? That I would get by doing 7 times 7 and finding that the area of the square is 49 centimeters squared, because I don't forget my units, right? Now you might be looking at this and saying, well, for this triangle, I don't have the height of the triangle. So even if I know that this side is 2 and this side is 13, uh, I'm not sure I'd be able to get the area of the triangle. Well, it's not asking for the area of the triangle. Now, if it did ask you for the area of the triangle, you guys would be able to figure a way out of that, right? If this whole bottom side is 2, then that makes this 1. And then I could think like I've got a 1 here is half the bottom. I got a little right angle there. Maybe there's some way I can figure out the height using a certain theorem, rhymes with Pythagorean theorem, right? And maybe you could figure out the height there, use that to get the whole area of the triangle, but it's not asking you to do that anyway. It's just asking for the area of the square. Here we've answered our question. The area of the square is 49 centimeters squared. But the main thing I want you to retain, again, is for these diagram questions, the main thing to do is always focus on how am I going to get an equation, how am I going to put an equal sign between two things that are the same as each other, two different ways of writing the same information. And if you can nail that, then you've got the knack for this type of question.